3 billion years ago, Earth wasn't looking for roommates. In fact, she was doing her level best to keep the place empty. No forests, no coral reefs, and certainly no oxygen. Just a vast, obsidian ocean and a chemistry so volatile it could melt the paint of a car. If cars even existed. It was a hellscape. And yet, here we are. So, how did life survive on a planet that seemed dead set on killing it? To find the answer, you have to go deep. I mean, really deep. Miles below the surface, where the sun is nothing but a distant memory. Down here, the seafloor doesn't just sit there. It cracks open like a furnace door. And from those cracks, the earth exhales. It looks like thick, black smoke, but don't let your eyes fool you. It's a cocktail of boiling minerals and gases that would drop any modern creature in a heartbeat. But in the shadows of those vents, something impossible happened. Tiny cells began to gather. They weren't waiting for a handout from the sun. They were like little factory workers plugging themselves directly into the planet's crust. They didn't need light. They had rock. They became living batteries, fueled by the raw, violent energy of the earth itself. Now, here is the thing about life. Once it learns how to thrive without the sun's permission, the game changes. Suddenly, the ocean isn't just an empty void anymore. It's prime real estate. If you can live off the planet's breath, you can go anywhere she leaks energy. But it forces a choice. And it's a choice we still recognize today. Imagine you are one of those single cells. Do you stay in the one chemical city of the vent where it's safe but crowded? Or do you risk the freezing, crushing dark of the open ocean to find something new? That choice, to stay or the spread, it's how the first empire was born. An invisible empire that started in the dark. And the strangest part, they didn't just survive in the world. They decided to rewrite the rules of the entire planet. Now, out there in the deep blue, there isn't much to hold on to. No leaves to graze, no prey to hunt, no meals as we know them. So, these tiny pioneers do something that feels, well, almost like cheating. They don't hunt for food. They mine for energy. Because when you strip it all down, food is really just a transaction. It's a trade. It's electrons moving from one pocket to another. And if you can intercept that flow, you can stay in the game. Some of these microbes, they have a taste for sulfur, that sharp, rotten egg tang of the deep. Others, they chew on raw iron, turning water a rusty hue like old blood. And then there are those who breathe methane, living off a gas that bubbles up from the sulfur like invisible champagne. Different menus, same mission, don't die. Once you see it through their eyes, the ocean stops being a void. It becomes a map, a network of invisible fuel lines, hot vents, mineral cracks, chemical leaks, little pockets of power when life can just plug in. But here is the catch. When energy is a rare commodity, every inch of that chemistry becomes high-value real estate. Now, imagine two microbial colonies drifting toward the same hotspot. Same sulfur, same iron, same tiny window of opportunity. What happens then? They don't have claws, they don't have teeth, but they have something much older. They have chemistry as a weapon. Some release acids to melt the rock and choke out the competition. Others build these slimy shells, we call them biofilms, to keep the toxins at bay. And some, they just grow, fast covering the surface like living paint until there is no room left for anyone else. Slowly, the seafloor begins to shift. Not from earthquakes or shifting plates, but from the sheer will of biology. Now, here is a question to keep in your pocket. If life at its simplest can fight, defend, and conquer, could it also learn to work together? Because the next chapter of this story isn't a war, it's a construction project. It's talking about the world's first cities built from slime, sunlight, and a whole lot of time. Now, you might think, in a world that cold and that lonely, it was every cell for itself. But nature has a way of surprising us. And yes, even the smallest among us learned the power of the together. They didn't do it out of the kindness of their hearts. No, evolution doesn't have much room for sentiment. They teamed up because in a world that's trying to kill you, teamwork is the ultimate survival hack. In the shallows of the ancient oceans, some of them stop drifting. They settle, they stick, they build. Layer by layer, they create microbial mats, thin living carpets that spread across rock like a slow tide. From above, they look like stains. Up close, they are cities, billions of cells packed together, each one doing a job, each one living in a different floor of the same structure. The top layer takes the harsh sunlight. The middle layers recycle chemicals. The bottom layers survive on whatever scraps and gases drift down. It's like an apartment building made of slime. And it works. Over time, those mats trap minerals and sand. They harden, they stack, and the ocean starts leaving behind strange stone fingerprints. Stromatolites, fossilized skyscrapers of microbial life. Here is the part that feels almost poetic. For a long time, Earth's most important architecture was built by creatures you couldn't see. But then, one group of microbes pull off the boldest move in the history of life. They stop living off the planet's leftovers and they tap the sky. They learn to harvest sunlight. At first, it's just a clever trick. Capture light, make energy, keep growing. But their success comes with a side effect. They start releasing a gas, something they don't even need. A waste product, oxygen. Now, to us, oxygen is the very breath of life. It's the stuff of poetry. But 3 billion years ago, oxygen wasn't a gift. It was toxic waste. Imagine a world where the very air begins to turn into poison. That's the irony of success. The thing that saved one kind of life was about to commit mass murder on almost everything else. Once oxygen entered the story, the planet didn't just change, it reset. Now, oxygen didn't arrive with a drum roll or a flash of light. It speeded in quietly, like a rumor whispered in a crowded room. At first, the oceans tried to swallow the evidence. This new gas made the dissolved iron in the water and locked it away, turning the deep blue into a dark, murky rust. Whole seafloors began to stain red. As as if the planet itself was bleeding minerals. But the microbes making that oxygen, they didn't stop. They couldn't stop. They were just doing what they knew, capturing sunlight, multiplying, spreading, and then the ocean filled up. You see, a sponge can only hold so much water before it starts to leak. The oxygen sink ran out, and that's when the very sky above us changed forever. Imagine being a microbe in that old world where oxygen was poison. Suddenly, the poison isn't a trace anymore. It's anywhere. This is a Great Oxygenation Event, one of the most brutal plot twists in Earth's history. Not a gentle upgrade, a chemical takeover. Whole ecosystems collapse, not because a comet hit, not because volcanoes own, because the air became hostile. And here is the quiet connection to our last story. Just one thread. We talked about how complex life needs cheap, reliable energy. Oxygen will become that. But first, it acts like a weapon. Because oxygen isn't just a gas, it's reactive. It tears apart delicate molecular machinery that evolved without it. So life splits into two fates. Some organisms retreat into mud, deep water, anywhere oxygen cannot reach. Others adapt, they build defenses, they learn to tolerate the toxin, and a few do something even smarter. They don't fight oxygen, they use it. They discovered that with oxygen you can squeeze far more energy out of the same fuel. It's like upgrading from a candle to a power plant. But that raises a dangerous question. If oxygen lets you extract more energy, what happens when life starts sharing tricks, sweeping solutions, stealing upgrades, learning faster than evolution should allow? Because the next secret of the microbial world is this. Microbes don't just evolve, they exchange. Microbes have a move that feels like cheating. If an animal wants a new ability, it has to wait, generation after generation, for slow mutations. But microbes, they can borrow. They trade genes the way people trade tools. A cell struggling in the new oxygen world might pick up a tiny instruction that helps it neutralize the poison. Another might gain a gene that lets it digest a new chemical, like learning a new language overnight. Sometimes it comes from a neighbor, sometimes it arrived through a virus, an accidental courier drifting through the water like invisible mail. So evolution stops looking like a straight family tree and starts looking like a web. And in that web, two great empires dominate the planet, bacteria and archaea. Bacteria spread fast and adapt fast, master of variety. Archaea survive where almost nothing should. Hot vents, salty lakes, acidic cracks, masters of endurance. Different strategies, same planet, same game. Here is a question to hold on to. If you can steal survival tricks from your rivals, what happens to the meaning of species? Where does one organism end and another begin? This is why the microbial world ruled for so long. Not because it was simple, because it was flexible. But even gene sweeping has limits. A borrowed instruction can only do so much. And then microbes discover something bigger than a new gene. They discover a new relationship. Because sometimes the most powerful upgrade isn't information, it's another living cell. One day, somewhere in the ancient oceans, a microbe engulfs another. It should have been a meal. But it isn't digested. It stays alive. And the invisible empire takes its first step towards something the old Earth never had before. Partnership that changes the price of living. And that partnership changes everything. Because when one cell keeps another alive inside it, it's no longer just survival. It's division of labor. One partner becomes a specialist at pulling energy from the world. First, efficient, relentless. The another becomes a home, a shield, a manager. A place where chemistry can be controlled instead of endured. In the microbial world, that's the closest thing to a miracle you will ever see. Two lives refusing the obvious choice, eat or be eaten, and choosing a third option, stay, work, evolve together. Now zoom out to the planet they lived on. For billions of years, energy was the price tag on every experiment life tried. Move costs energy. Repair damage costs energy. Build defenses costs energy. Coordinate with another cell that costs a lot. So when life finds a way to make energy reliable, the impossible starts to look affordable. Not granted, but possible. And here is the quiet truth that makes this ending feel bigger than an ending. Microbes didn't just survive on Earth, they engineered Earth. They learned to recycle carbon, nitrogen, sulfur, keeping the planet's chemistry in motion like a slow global heartbeat. They rewired the oceans with invisible reaction. They built cities of living mats that trapped stone. They changed the sky with a gas that began as poison and became power. They traded genes like shortcuts, turning evolution into a web. And they invented partnerships that would eventually pay the energy bill for complexity. As Stephen Jay Gould put it, on any possible, reasonable, or fair criterion, bacteria are, and always have been, the dominant forms of life on Earth. So the microbial world didn't end, it simply became the foundation, quiet, ancient, everywhere. It's still in the deep sea, feeding on rock and heat. It's still in the soil, turning death into nutrients. It's still in you, working in the dark, keeping the lights on. And when you realize that, the world looks different. Not like a stage where microbes are background noise, but like a planet whose main engine has always been invisible. If you want the next chapter, the moment a cell builds a true command center, the birth of the first complex cell, subscribe and stay with our channel. Because the next chapter gets bigger, stranger, and far more personal.